Hello, Augies Worldwide. I'm Dave Kassler, amateur radio call sign KE0OG, here with another episode of Ask Dave. Today is an interesting one. I was contacted by a company called Golden Mate Energy, and they make large lithium iron phosphate battery packs. Okay, and these are real nice ones. They're not terribly expensive. And so they sent me one that I could use. Now what I have done is I've taken my entire solar storage system, all the lead acid batteries that I have, they're offline. And I'm using just this one battery, which is a 100 amp hour battery. It's a big battery. And I've got a lithium ion charge controller for it, a solar panel, and we're going to go that way and see if we can use it. Now, what I'm going to do is go through a few charts here that show how I've got the thing installed. I'm also going to mention a charge controller that I got from Impulse Electronics last year at Pacificon in 2022, and how I've got that hooked in and how everything seems copacetic. Let's look at the charts. Okay, so this is the battery that they sent me, and I'll make a disclaimer right here. They sent it to me for free. Okay, and this is about a $300 battery. The part that you see up in the top here is the battery management system, and then this down here is the actual battery pack. Let's take a closer look at some of the specifications that are on the front. The voltage to charge it is 14.4 with 14.6 max. I have a small charge controller that puts out 14.6. Now the way that you charge these smart lithium ion batteries is you provide them with between 14.4 and 14.6 volts, and they take care of the rest. They'll take the current they want. They'll turn it on when they need it, turn it off when they don't, and so on. Now, the charge current can be up to 20 amps max. Okay, or I'm sorry, 20 amps or 50 amps max. 50 amps happens to be 1/2 of C, which is the capacity of the battery, because it's 100 amp hours. Okay, now what's interesting is that you can charge this pretty fast. I'd keep it down here about this rate. Now my solar panel, which is a 24 volt panel, provides about 7 amps. And so the converter that charges the battery will change that to about 14 amps. So we're well within limitations here. The continuous discharge current is 100 amps. Now that's interesting because my amplifier is a 12 volt amplifier, and it takes up to 75 amps of current to make the thing go. I'm very tempted to try adding my amp in here and see how that goes. Now the operating temperature, they want above freezing when you're charging it. Above freezing. Discharge can be much colder. Not hugely colder, but much colder and much warmer. The user manual consists of a single page. It's got the user manual. This is the front of it. This is the back, which talks a little bit about service and all that sort of thing. Let's look at the what's inside. Product specs, electrical specs, nominal voltage 12.8. I do not believe that. I think the nominal voltage is about 13.4. If for some reason it gets down below that, the battery management system will cut it off. And when it seems like nothing's coming out of the battery, try charging it. When you get up to about 14.6, it'll say okay and come back. Nominal capacity 100 amp hours. That's at a rate of discharge of 0.2 C. And remember, I said the C was the capacity, which is 100 amp hours in this case. This is at 25 degrees centigrade, which is basically normal room temperature. The energy in it, 1280 watt hours, they made just by multiplying that by that. That's it depends on the rate at which you take it out. Resistance is for any kind of AC currents flowing through it, very small. The cell type, lithium iron phosphate, which is the safe type, okay? So a combination of the chemistry and the battery management system keep this battery safe. There's your dimensions, net weight about 13 kilograms. It is much lighter than a comparably sized lead acid battery. Terminal types are just screw, ABS plastic. Okay, the charge voltage, you offer it 14.4 or up to 14.6 max. The standard charge current is at 20 amps. Well, I don't have anything that will provide that, but I do have something that's up to about 14 amps that will keep this thing plenty charged. The maximum charge current is 50 amps, but you're going to get the battery hot if you try and charge at that rate. And if the battery management system senses an over temperature, it will shut it down. The discharge specification, maximum continuous discharge current's 100 amps. That's a lot. Okay, the discharge cutoff voltage will be about 10 volts, and that's well past. The thing should stay above 13 for just about its entire charge life, and then it disappears pretty rapidly. You cannot tell the state of charge of a lithium-ion battery by looking at the voltage. Now, on lead acid, you can, but not here. Okay, the temperature specs, yeah. Don't let it freeze. Compliance specs, it's got a bunch of stuff right here. This is interesting, cycle life. Now, 0.2 C means, C is the capacity. So this is if you discharge it down to the point where it only has 20 amp hours left. That's also an 80% depth of discharge. Okay, 25 C is the nominal temperature for that. Most lead acid batteries do not like being discharged that much. Now, the big lead acid batteries, the AGM batteries that are designed for solar systems, can be taken down to a fair depth of discharge, nowhere near 5,000 times. But the batteries that I have, my AGM lead acid batteries, I think I've probably let pretty well discharge only twice since I've had them. I've had them about 15 years. Okay, so now here's another thing. Do not use as a starting battery, because that will cause the voltage, it'll pull the voltage down, and it will cause problems with the battery, and the battery may just shut off. Okay, do not immerse in water, because remember, you got that battery management system in there. I don't know how children would operate this product, but certainly keep them away from it, because it's got a huge capacity. And if they were to connect metal across the two terminals, you could have a real problem. Now, notice on here that on top are these little orange snap-on things and you'll notice that the wires I've got here go under those. That helps keep it protected. Okay, you can put up to 4 in parallel or 4 in series. All right, so now let me just show you a battery management system. This is a sample from another battery, and it sits on the top. Okay, it's connected in all the right places, and it's got a lot of electronics, including a little microprocessor right here that manages the whole thing right here. It is supposedly fail-safe. If something is going wrong, it will cut it off, completely disconnect it. Here is where I have mine located. It's underneath the table, out of foot reach. In fact, I've got a J-pole antenna in here in this box sent for testing. I did one video on it already, so my feet won't get to it. And it is plugged up here into my little Red Mountain Radio, I think it is, distribution panel here. Okay, and I'm using power pole connectors throughout. This is very heavy wire right here. This is what came with the power pole connectors. Okay, now there's another thing I'm going to show you a little later that I've done. This voltmeter that I have right here, I've put a Zener diode in there with it, so it actually starts moving at 10 volts. There's 11, there's 12, and then it's fairly linear up here. These were actually put on while measuring the voltage. 12 volts, 13 volts, 14 volts right here, and you can see it's going up to about 14.5. Then here is the charge current. This can become quite a bit more than this, but right now it's showing about 2.7 amps. That's because I put my own shunt on this, and this is in a circuit that I got out of somewhere that uses a Zener diode as a reference, so it's an expanded range voltmeter. Now I charge it with the solar panel. This is the panel. It comes from a local outfit called Atlasta Solar. The Atlasta Solar store. Now, if you were to pronounce that slowly, it would be at last a solar store, and I think that's what they intended. It's in Grand Junction. They're extremely active, selling people on the idea that they can get a loan to put these solar panels in place, and that it will pay itself back by the amount of energy that you get from the solar panels. So you'll end up at the end of the period, your electric bill goes down, and of course you're paying the loan off, and then at some point you own it and it still continues to work. These things last pretty much forever. I know some people have said, maybe 30 years, but that's still a long time. This is a 240 watt panel and 24 volts. So you need a charge controller for this. That's this. Here's a little meter I have. This is the solar panel voltage and how much current is coming in. Not very much current, 70 milliamps right at the moment. So this tells you the state on the solar panel side. This is the spec on the solar panel. It's a WS-M300. It puts out 14.6 volt constant. Your photovoltaic input has to be between 20 and 50. So a regular 12 volt panel won't do it. You'll need to get a 24 volt panel. I would not get a 48 volt panel because this 48 is a nominal voltage, and in pure sun, beautiful, nice, clear day, it will go well above 50. So get a 24 volt panel. Okay. This is the actual charge controller here, available from impulseelectronics.com. They're a small outfit out in California. I picked this up at PacificCon last year, and I hope they'll be displaying again, because I want to tell the owner what I've done with this battery here. Okay, so if we look at what the solar panel thing does, it'll go up to 300 watts. Okay, it's specifically designed to charge the Bioenno 12 volt type lithium iron phosphates. Well, the battery I have here is functionally the same as that battery. Okay, it's a maximum power point tracking controller. Okay, so as the input voltage from the 24 volt nominal panel can go up into the 36, 37 volts, which we saw a moment ago. All solar panels are like that. So it puts a constant 14.6 volts out, and the battery management system takes it from there. Okay, maximum current 24 amps. Okay, we'll only go up to 14 amps with this particular panel. You could put another panel in parallel with this one, but I don't see any particular reason to do that, because if you run the numbers on this thing, it's going to run my station as much as I want to do. Okay, so conversion efficiency 95%, meaning it's not going to get very hot. It does have short circuit protection and all of that. Something important I want to point out. Here's your battery, and you've got it connected to your distribution panel where your rig and your VHF rig and everything else is connected. Okay, so this arrow is plus and minus. The source, which is the solar panel and controller, should be connected directly to the battery. If you connect it up here in the distribution panel, yeah, it will charge the battery. But if you lose the fuse for this, then you've got the source talking directly to your equipment. So bring these cables and these cables, put them right on the connectors on the battery to keep it safe. You can buy this battery directly from Golden Mate, okay, and they're a Chinese company, but they ship from the United States, okay. Or you can buy it from Amazon, slightly lower. Now, I draw your attention to this yellow box right here. This is a code. You go to amzn.to and put in 48 cap P, cap K, cap Z, small b, cap V. It will take you directly to this page. And if you buy using that code, it will not cost you any more. However, it will help support the channel. Now, what are my future plans with this? The new 100 amp hour battery is installed. It is now powering my station. I'll run my station, all of the radios except for the amp, and I'm tempted, because of how much power this can put out, to put the amp on there too. It takes 75 amps to run that, and of course I need 23 for the station itself. So I think we'd be right at the edge of capability. But I'm going to run my station on solar exclusively for several months, and then I'll provide a follow-up report. So there you have it. A rather interesting battery. I've always wanted to have a battery like this. I've had these lead-acid batteries for well over a decade. They're still working just fine. I put very little load on them and keep them fully charged. So we're going to go lithium ion here, and we'll see how it goes. And I'll give you a report after a few months. We'll see what happens. If you use that code I showed you, it will help the channel. Now, after I sign off, there are some charts. There's how to contact me. There's how to contribute to the channel if you'd like to help me out. And there's a list of all the patrons, the PayPal supporters, and new this month, we've got the Super Thanks members who are here, and also the people who've dropped a tip. You can still tip. Go to the tip jar, and it'll take good care of you. So be sure to check the following charts. And until we next meet, 73.